Okay, so we are going to start chapter 3. Go ahead and open from Canvas. Go ahead and open that chapter 3 practice.
Chapter 3 what?
Practice. We'll open up the chapter 3 practice. Clear off of it. So in chapter 3, we're really learning all about cost behaviors. So really what we're going to talk about is like fixed versus variable costs and how those affect our total costs. So it's really important to be able to classify costs as fixed versus variable and understand. And we also have mixed costs, which have fixed and variable components, but we'll focus mainly on fixed and variable costs. It helps us understand how costs are changing, based on different factors. So when we talk about fixed costs, we know we're talking about, costs that are the same month to month, like our rent on factory or depreciation, things like that. So we know with fixed costs, we have to pay those fixed costs every month, that same amount, regardless if we sell 500 units or 0 units or 15,000 units, right? So that's one important thing to remember. But then variable costs are costs that will change or go up or down based on units of production. So, fixed costs we have to pay regardless. And then variable costs, like direct materials. Well, we obviously, if we're making more product, we're going to have to buy more materials. So understanding those relationships between fixed and variable costs really kind of make a difference on how we look at costs. And we'll use a lot of what we learned in this chapter in future chapters when we're evaluating cost behavior even further. So really this chapter is laying the groundwork for understanding how costs function. So that way when we look at making decisions based on costs, we'll be able to identify, is that a cost that's relevant to our decision? And again, a lot of this we did in managerial accounting, like we dealt with fixed and variable costs and all of that. We're just going a step further and we're learning a little bit more advanced. We're going to do, like in managerial accounting, we did the high-low method to find costs, to do a cost formula. We're going to do that in here, but we're also going to do what we call a data regression. And today we're going to look at some that they've already done and ran for us. And the next class period, we'll actually run a regression in Excel, and then that'll be your project in this class. It's not very lengthy, thankfully, but it's kind of cool because you can see how easily you can run data in Excel and get results that then you can use for predicting cost behavior. So it's pretty cool. So as far as chapter 3 goes, again, we're really just focusing on being able to identify costs, and then we're focused on being able to estimate costs moving forward. So a lot of these things will help us in further chapters. So our big thing is on your notes there, just talking about like writing a cost function, basically. So basically, total cost equals fixed costs plus the variable unit times, cost per unit. So let's say it's a separate times number of units. So one important thing to remember is our total cost formula. So total cost equals our fixed cost plus our total variable cost. And total variable cost is always our variable cost per unit times however many number of units we produce, okay? So kind of the takeaway from this when I look at that cost function is that if I know 2, I can usually calculate a third. And that's kind of what we're looking at. If I know my total cost and I know my fixed cost, then I can figure out what my variable costs are, okay? Or if I know fixed and variable, I can calculate total cost. So that's kind of our goal here in this chapter, is to figure out what our costs are. And once we know these costs, then basically, if we know our variable cost per unit and we know our fixed cost, we can find our total cost at any level of production. Okay, so that's kind of our goal in this chapter, is to be able to write a cost function and then be able to use that cost function to say, well, what if we made 20,000 units, or what if we made 10,000 units? We could calculate a total cost once we have that variable cost per unit and we know our fixed costs. We can calculate costs at any level of production, which helps us for planning and budgeting and, you know, all of that. So it's just kind of dealing with that. And then, like I said, we're going to learn different methods to come up with those cost estimates. Okay. So we're going to look at data, look at costs, and be able to take those historic costs and write it in a cost function. So then we can solve for any level of production. And again, that data will help us in further chapters be able to do more important calculations as well. So let's get into this. So it's kind of wordy, but it's really not too bad. So it says, Callie's Gym is a complete fitness center. Owner Callie employs various fitness trainers who are expected to staff the front desk and to teach fitness classes. While on the front desk, trainers answer the phones, handle walk-ins and show them around the gym, answer member questions, do light cleaning, and then the trainers also teach fitness classes according to their own interest and training level. So the cost of fitness trainers is $600 per month, and then an additional $20 per class taught. Last month, 100 classes were taught. So with all that information, we can calculate what our total cost of employing fitness instructors are. And that's kind of what we're looking at. In this case, we're paying them both a fixed rate and a variable rate of employment. So putting it into a cost equation is pretty simple on this one, because what's my fixed cost? 600, very good. And then how much do they charge per class taught, or how much do they get paid? 20. So there, if I developed a cost equation, my total labor is 600 fixed plus $20 times however many classes are taught in the period. So if it says, what is the total variable labor cost for last month, I'm just kind of taking that formula and plugging in what I know. So 600 plus 20, and we taught 100 classes. So times 100. So I'm just plugging in the number of classes we taught and multiplying it by the $20 per class. So all total, my variable cost for the month is $2,000. $20 per class at $100 or 100 classes. So $2,000 is my variable cost. So what's my total labor cost? $2,600. Very good. Well, we start simple, right? So we this one's nice and simple. So we know our total cost is $2,600 for the month. Okay. And then it asks, what was the unit cost of labor per class for last month? 26. Very good. So you took the total cost of 2,600 divided by 100 classes. We taught 100 classes. So our unit cost of labor per class is $26. So on the next step, it's a what if. It said, what if Callie increased the number of classes offered by 50%? Well, how many classes would we be offering then? 150, right? So that's right. We take 100 times 50%. So we're offering 50 more classes. So we're offering 150 classes total. Well, then I'm just rewriting my cost function. Do fixed costs change? No, they stay the same. So my 600 stays the same. Do my variable costs per class change? The $20, does that change? No, it stays the same, right? We're still paying them $20 per class. The only thing that's changing is we're now teaching 150 classes. Okay. So what's my new total labor cost?
3,600.
Very good, 3,600. So my new variable cost is 3,000. And then I add in my fixed of 600. So my variable cost changed. So now I'm at 3,600. What's my unit labor cost now?
$24.
Very good, $24, because you divided by the 150 now, right? So we took 3,600 divided by 150, and it's now $24. So why did it go down?
Because the fixed cost goes down.
Right, your fixed cost per unit goes down, right? So that's how fixed cost works. Basically, we're able to cover more fixed costs when we increase, you know, our classes offered, okay? So with fixed costs stay the same, the total fixed cost for the month. But fixed cost per unit changes based on levels of productivity, okay? So total fixed costs for the month to month stay the same, but fixed cost per unit will change based on production, which is the opposite of variable, right? We saw variable costs, our variable costs changed based on production. You know, our total variable costs changed based on production. We went from 2,000 to 3,000. But if we were to calculate, this is our unit variable cost, right? This $20, it didn't change. So with variable costs, variable unit costs stay the same. But with production changes, total variable cost is what we see change. So they're kind of like, they have an inverse relationship. Okay. Does that make sense? Okay. So that one's pretty simple, but it's just kind of getting us to see how costs change, both fixed and variable cost. Okay. Let's go to the second one. Second one is kind of similar. We're still looking at cost functions and creating a cost function. Corazon Manufacturing has a purchasing department staffed by 5 purchasing agents. Each agent is paid $28,000 per year and is able to process 4,000 purchase orders. Last year, 17,800 purchase orders were processed by 5 agents. So what we're going to do in this one is we're going to use cost functions to determine if, you know, we're actually maybe having purchasers that are working and not doing something. Do we have more purchasers than we need, or do we not have enough purchasers? You know, what do we need here? So we can kind of see with this problem, what we're going to talk about with capacity is, do we have purchasers sitting there not working, or are they overworked? Which is kind of important, right, with managing employees. So we're looking at a cost function. We're also kind of looking at a human resources situation too, because we know, obviously, if we were overworking those purchasers, they're probably going to quit. But if we're underworking them, well, we're overpaying them. So we have 2 separate issues here, possibly. So what we're going to do is we're going to calculate all these costs and try to figure out, are they over or underworked? Okay. So on number 1, it says calculate the activity rate per purchase order. So how would I calculate the activity rate per purchase order? How much are they getting paid? If they're capable of producing or processing 4,000 purchase orders, how much are we paying them per purchase order?
You take the 20 or 28,000, 4,000.
Yes, yeah, you got it. Yeah, we'll just take the total amount we're paying them, the 28,000, divided by the total that we think they're capable of producing or processing. And we're basically paying them $7 an hour, or per purchase hour, sorry, per PO, not an hour, per PO. But that's if they're actually processing 4,000 purchase orders. So that's the rate we're paying them at, based on the labor that we're charging. So then it says calculate in terms of purchase orders, the total activity availability. Well, if we have 5 agents, how many total purchase orders could they process?
20,000.
20,000, good. 5 purchase orders, or 5 purchasers, 4,000 purchase orders. Multiply that. So we have the capacity with our 4 purchasers to process 20,000 purchase orders. Are we processing 20,000? No, we're only processing 17,800. So what's our unused capacity? 2,200. Good. We take the 20,000 minus the 17,800. And with the labor we have, we could process 2,200 extra purchase orders. Well, let's put that in cost terms, because that's what we care about, right? Money. So it says calculate the dollar cost of the total active or activity availability. So if we were truly processing 20,000 purchase orders, how much money would that be worth?
140,000.
Very good, 140,000. Well, how much money are we losing by not processing the full capacity, or what's the unused capacity?
How did you get 140?
Oh, we took the 20,000 purchase orders times the $7 per purchase order.
Oh.
Yeah. I think I heard the unused capacity. Would you say, Mark? Very good. Yeah. To get the unused capacity, what we're not processing is 2,200 purchase orders times 7. So 15,400. Okay. So basically we're overpaying, right? So we have 4 purchasers. Do you think we need 4 purchasers to meet our demands? Probably not, right? So let's look at number 4. So number 4, it just says express total activity availability in terms of capacity used and unused capacity. So a lot of words there. All they're saying is we're basically putting what we have up here, our total available and our unused, in a cost function. So we know our total availability is 20,000 purchase orders. And right now we're using 17,800, or that's what we're actively doing. And then our unused is 2,200. So on that, we're just putting it in kind of a function based on purchase order numbers. And then right below that, they're asking for it in dollars. Well, we've already calculated that too, right? We had our total activity availability was 140,000. And we knew our unused was 15,400. So how much did we actually use? Very good, 124,600. So we could subtract, right? You could take 140 minus the 15,400. Or you can also get that 124,600 by taking the 17,800 times 7. Either way gets you the right number. Okay. So it says, what if one of the purchasing agents agreed to work half-time for 14,000? How many purchase orders could be processed by 4.5 purchasing units? Or agents, sorry. 18,000, good. So we took 4.5 times 4,000 POs per person, and we could then process 18,000 purchase orders. What would our unused capacity then be? 200. Good. So by dropping down to having 4.5 full-time processors, that frees up, or gets it to where they're actually processing more closely to what our output is. So now we only have unused of 200, which again, if we wanted to look at that in dollars, we just multiply it by $7. So the purpose of this one is just looking at how when we look at cost behavior and look at fixed versus variable and all of that, we can identify that we don't need 5 full-time processors. Now, if capacity increases again, next year we start producing and we're needing more POs processed, that 4th person may need to go back full-time. But right now, at our current capacity, at our current level of POs, we only need 4.5 purchasers. Okay. Any questions on that one?
On the 18,000,
Uh-huh.
you did the 425 times.
Oh, by 4,000. So you have 4.5 processors, and we took it by the 4,000 purchase orders they could process. Any other questions on that one? Okay. Okay, so the next one is where we get to start doing some fun. So on this next one, they give us 12 months of data on purchasing cost and number of purchase orders. So what we want to look at is they give us our total purchasing cost for each month and our total number of purchase orders. And we think number of purchase orders is driving purchasing costs, like it's an activity driver or cost driver. So with that, we think we can take this data and figure out, we want to calculate what our fixed costs would be and our variable rate per purchase order. So when we are given data like this, and we'll look at regressions in a little bit, but this is when we're assuming, like I said, the number of purchase orders is driving our purchasing cost. So because we think they're related, we think we can use this data to figure out what our cost per purchase order is, and then what our fixed costs are. So high-low method, and it's on your notes, but we'll go over it. High-low method is an estimate. So here we're really looking at cost estimates. They're not solid, guaranteed costs. But the purpose of using estimates is that we can take those variable cost estimates and fixed cost estimates and use them for planning. We're going to know at the end of the period what our actual fixed costs are, variable costs, so we can compare it and do all of that. But just for planning and making decisions, we're going to use these estimates. So normally we want at least 12 months worth of data to kind of base that off of. And one method we could do is we could chart it. We could put it on a chart and see a relation, draw a line, kind of get rid of any outliers and find some type of cost formula. But we're not going to do that right now. We're going to look at what we call the high-low method. So the high-low method is just a way to estimate costs, okay? So we're given total cost. Our purchasing cost is our total cost, and our number of purchase orders is our units of activity. So what we want to find is our fixed cost and our variable unit cost, okay? So the first thing we are going to solve for is our variable unit cost. So using high-low, to get our variable unit cost, we're going to use a formula that we take the cost at highest level of activity minus the cost at the lowest activity level and divided by highest activity minus lowest activity. So what I want to look at first in my data, and I'm always going off of activity levels. That's where most people kind of get off on the high-low method, is I want to look at actual activity levels. So I'm looking at my number of purchase orders to identify my highest cost and my highest activity. So what month do we have the lowest month of purchase orders?
August.
That's the highest.
Oh, well.
Yes, that's the highest. Good job.
Lowest is February.
February. Okay. So yeah, our lowest month is February. Lowest activity month is February.
The lowest cost or the lowest activity?
The lowest activity. So yeah, that's where high-low people get off because we look at costs, but you actually want to look at the activity level itself. Yeah.
And that's the number of orders.
Yes, yeah, we'll go off the number of orders. And so for this 12 months, our lowest order was 330, and that's February. So I'm going to write these on the board. So this is our lowest, 18,065, 330 units. And then our month of highest activity is August. And in August, our cost was $20,940. And our purchase orders were 560. So that's the first step with your high-low method, is you want to identify your month of lowest activity and your month of highest activity. Okay, so there we went off of actual purchase orders, not costs. A lot of times they're the same, right? If you look at August, August is also the highest cost. But if you notice, February is not the lowest cost. But I want to choose the month of the lowest activity and the month of the highest activity. So now I have the data, the cost and the number of POs at the lowest activity level and the highest activity level. Then I can put it into my formula. So I take my cost at the highest, so 20,940. I subtract out my cost at the lowest of 18,065. And then I take my activity at highest, 560, minus the lowest activity of 330. So when I do that, you should get 2,875 divided by 230. So what is my cost per purchase order?
$12.50.
Yeah, $12.50. So $12.50. So using the high-low method, after identifying my lowest activity and my highest activity data, I take my cost at the highest minus the cost at the lowest, divided by highest activity minus lowest activity, and I get $12.50. That is my variable cost per unit. Okay. So now, out of my total cost function, I know my total cost, I know my variable cost per unit, and I know, if I use some of this data, I know my total cost and my number of units. So now I can use that to solve for my fixed cost. Okay. So you can do it, you can pick either month. We're going to use data from either month to solve for my fixed cost. So which one did I use? Okay, so we'll use our high. So I'm going to choose to use my August data to solve for fixed costs. Well, now I know my total cost is $20,940 equals, I don't know my fixed costs, plus I know this stuff. So I know my variable costs are 560 times $12.50. Okay. So what I want to do is solve this equation. And I gave it to you on your notes as solving directly for fixed costs. I just wanted you to see where I got that formula. So to solve for fixed costs, well, first of all, I'm going to calculate my variable cost. Okay. I'm going to calculate my variable cost, which is what, 7,000? So when I take 560 purchase orders times 1250 a purchase order, my total variable cost is 7,000. Okay. Well, using algebra, because everybody loves algebra, right? I can solve for fixed costs by subtracting 7,000 from both sides of the equation. Okay. So when I do that, I get fixed costs are equal to $13,940. So again, on your notes, I just tell you fixed costs, you're going to take your total costs minus your variable costs to solve for fixed costs, okay? Again, I could plug in my February data instead, and you'd get the same amount. You could take any level really, and you should be able to get the same amount, but definitely those highest or lowest points. So now I have my fixed costs. I have all my costs, okay? So I kind of already did a lot of this, or we did. So determine the high and low point. Well, we already figured that. The high month was August, and our low month was February. And then we calculated our variable rate was $12.50 per purchase order. And then we just calculated our fixed monthly cost of $13,940. So on part 4, it says write the cost formula for the activity showing the fixed cost and the variable rate. So total purchasing cost equals fixed cost, which is $13,940, plus our cost per unit of $12.50 times purchase orders, or number of purchase orders. So the cool thing now, once I have that cost formula, I use my high-low method to find my unit variable cost and my total fixed cost. I can now use that cost function to determine costs at any level of production. So that's kind of our goal here. So then on part 5, it said, well, if Doheny Manufacturing Company estimates that next month we'll have 430 purchase orders, what is the total estimated purchasing cost for that month? Well, I ran out of room. But how would I calculate that?
430 times the 1250.
Very good.
Cost of 13,940.
That's right. Very good. So yeah, we just plug in 430 for our purchase orders. So you're absolutely right. We would take 430 times the 1250, multiply that, and then add in the 13,940. I kind of have room. Right? 13,940 plus 1250 times, was it 430? Mm-hmm. Yeah. And then we'll know. So what are my total costs?
19,350.
Very good. $19,315. Okay. So at any different level, if we estimate we'll have 8,000 purchase orders, which would be a little out of range, right? But we could calculate costs though based on that now because we have a cost function. Let's see, part 6. What if Doheny Manufacturing wants to estimate purchasing costs for the coming year and expects 5,340 purchase orders? So we've been doing by the month. So how would I change that to do a cost function for an entire year?
Multiply your answer by 12.
Very good. All of your answer, your total answer?
Your total, right?
Would you?
Just the total purchasing cost times 12.
Just the fixed costs.
Yeah.
Yeah. It's a trick question, right? So right, they've given us the total number of purchase orders. So that 5340 will still be multiplied by 12.5 to get the total variable cost. But this fixed cost, this 13,940, is only for 1 month. So to get the total yearly, I would take the fixed cost of 13,940 times 12 months. Then I would add in the 1250 times, what is it, 5340? 5,340. So since it's for the whole year, we need to multiply our fixed cost by 12 to get 12 full months worth. So what would my total purchasing cost be?
234,000.
That sounds right. Yeah, 234,030? Okay, yeah, perfect. So yeah, our total estimated purchasing cost would be $234,030. What is the total fixed portion?
Wouldn't it be the 12 times the 13,940?
You got it. Yep,
167,280.
perfect. Yep. 167,280 because we took the 13,940 times 12. Very good.
I'm sorry.
No, you're fine.
On number 6,
Uh-huh.
you took the fixed cost times the 12 months,
Uh-huh.
and then the 430 times 1250 times 12 months.
Oh, you used the 5340 here.
Oh, okay.
Yeah, so
Times
5340 times 1250.
Oh, times 12.
With your variable costs, you don't have to worry about multiplying it by 12 because that's a whole year's worth of purchase orders. So we just take the 5340 times the 1250 per purchase order. So this one's kind of obvious now because we've already done it. But why doesn't it equal the fixed cost in requirement 3? Exactly, because there's 12 months. So we had to calculate fixed costs for an entire year and not just the month. Okay, any questions on that one? So that's one way of estimating costs. So using the high-low method again, we can take a 12 months worth of data or more, and figure out, calculate our variable rate and then calculate our fixed cost. So the next one, I believe is the same data, but now we're talking about regressions. So regression is just really a more accurate way of coming up with cost estimates. So to do a data regression, and we're going to do one next week in Excel, they've already done one for us. But what a regression does is it takes this data, these purchasing costs and these number of purchase orders, and it tells us, number one, it tells us if the computer thinks that number of purchase orders is actually a cost driver for purchasing costs, which is kind of nice. And number two, it actually gives us some of our outputs for us, like our unit cost. So we have less calculating we have to do because, as you've heard me say, I'm sure, Excel's like a giant calculator, right? So it'll do a lot of work for us. And it's actually, if you know how to input it, which we'll learn how to do that next week, it takes all the work out of it for us. And it returns a lot of statistical data that we won't look at because it returns a lot of data. We'll leave that to the, stats people. but it does return some data that we can analyze and look at as accountants. So the high-low method's great as a baseline, estimate, but when we use a regression, we're usually able to get a more accurate estimation. Okay, so you'll kind of notice they talk about these new words. They have intercepts and X variable 1. It's like, what in the world does that mean? Well, it tells you on your notes because that's kind of confusing, right? So your intercept is your fixed cost. Okay. Intercept is really just equal to your fixed cost. I think I write it in there somewhere. Yeah. And then X variable 1 is your cost per unit, your variable cost per unit. Okay. So again, on this example, they're just telling us, hey, we ran the regression for you, and we got an intercept at $15,021, and we got an X variable 1 of $9.74. So again, what that means is they ran the data, and they got $15,021 as the fixed cost, $9.74 as the unit cost. So again, let me just look back. I forgot what our original cost function was. When we used the high-low method, we got, our fixed cost came back at like $13,940, and our unit cost was $12.50. So it's different, right? It's the same data, but the computer analyzes it a little differently. And they look at like outlier data that may be off. Maybe we only had 3 purchasers one month, and so productivity went down. It considers those outliers and things like that. And so it's just a little more accurate. So when we're writing a cost formula using regression data, it's really the same thing. Your total cost is going to equal your intercept plus X variable, so I just put X, times the number of purchase orders. I'll use an asterisk there. Okay. So it's really the same function. We're just using different words. So again, intercept is really your fixed cost, and your X variable 1 is your cost per unit. So when I write the cost formula, total purchasing cost equals $15,021 plus $9.74 times the number of purchase orders. So when they run their regression for us, it's actually easier, right? They give us the answers. We didn't have to do any calculations or any math. No one ever complains about not having to do math, right? So then we're doing the same thing. We're using the same estimations. We have a different cost formula. Okay? So it says total purchasing cost equals $15,021 plus $9.74 times purchase orders. So in part 2, we use that data, $15,021 plus we have $9.74 times 430 purchase orders. Okay. So from there, it's really repetitive. We're just doing different numbers. So what would be my total purchasing cost if we processed 430 purchase orders?
19,209.
Very good, 19,209. So again, we take $9.74 times 430 purchase orders, and we add in our fixed cost of $15,021. So then, as you can see, the what if is the same as well. So we're still doing another whole year's worth. So I would do the same thing with my cost function for number 3. What if it was for the whole year and we expect 5,340 purchase orders? Well, we would take the 15,021 times 12 to get our total fixed costs plus 974 times 5,340. So what is my total cost for the year?
$232,264.
Perfect. 232,264. 232,264. Well, how much of that is fixed cost?
19,252.
Very good. 180,252. So all we're saying there is out of our total cost, the 180,252 was the fixed portion. And then total cost was 232,264. And then clearly it's the same as the last one, right? The reason our fixed cost is not the same is because we're looking at a year's worth of fixed costs. Or there's 12 months in a year. Any questions on that one? I like this chapter. I like cost estimates and functions and formulas. Probably because I teach Excel. It's my happy place, right? A lot of people are like, ew, but if you like, plugging in numbers, it's kind of fun. And I just think it's cool that you can do all of that, so many different methods of cost estimates.
Oh, I'm creating so many spreadsheets already.
I love it. See, that's just like,
It's fun. I like it.
I'm like, let me see your spreadsheet. No. If only we had time, right? No. And that's when my husband's like, you're such a nerd.
I've heard that already.
He likes spreadsheets too, just not as much as me. He likes it when I show him stuff that makes his life easier though. Yeah.
They get it more.
Mhm. Okay, I think we're on our last one. And again, we're going to actually do our own regression next class period. So we'll talk more about like the rest of the stuff that's on your notes when it's talking about correlation coefficients and all that stuff. We'll talk more about what that data means next week because we're just focusing on the intercepts and the X variables. But yeah, it's not as bad as it sounds. It's not too bad.
Sounds a lot like statistics.
It is a little stats driven. But again, the computer does all the work. We just, like put it in a cost function and move on. We just look at it and go, oh, that is a direct correlation. Because really all it means is like when we put this data in. So now in this example, it's the same. Notice our purchasing cost and our number of purchase orders are the same. But this manufacturing company was like, well, number of purchase orders definitely drives purchasing costs. But what if there's other functions that we're doing? There's other activity or cost drivers. And so the controller felt that the number of purchase orders alone did not explain the monthly purchasing cost. So for example, he knew that non-standard orders, ones requiring overseas suppliers, for example, took more time and effort. So perhaps that was also driving costs. Probably labor, right? If they take more time, there's going to be more labor costs and more supply costs, all of that. So he collected data on the number of non-standard orders for the past 12 months and added it to our data. So this is what we call a multiple regression. So a multiple regression is just when we think there's more than one cost driver. So more than one activity that's driving this total purchasing cost. And again, it just helps us kind of drill down a little bit and estimate our costs better. Because if we base it just on purchase orders, but non-standard orders are taking up a lot of time, we may not be planning and estimating our costs accurately. Again, they're just going to give us the intercepts and the variable costs. But when we run regressions, it's also going to give us some statistical data that tells us whether or not number of purchase orders and number of non-standard orders are actually predictors of our total purchasing costs. So running a regression does two things. It gives us an idea if these actually are cost drivers, and it gives us good cost estimates. So with a regression, because with the high-low method, we don't really know, do we? We could put in, the cost could be totally wrong. So it's an estimate, it might be accurate. But when we do regressions, we get that extra layer there that tells us are these actually cost drivers? Because maybe this isn't a cost driver. Well, then we know we can go back to our first model on our single regression. So it just gives us more data, which, you know, as accountants, we want all the data, right? Maybe not, but. So when we run a multiple regression, what happens then is we just expand our cost equation. We make it louder. And you can do more than 2. You can do 3, 4, 8 million. Don't recommend it, but we could. It's usually like 2 or 3 though, just to be honest. It's usually not 8 million. I haven't done one with that many. Anyway, so multiple regression was run on the above data. And we get an intercept. So again, that's our fixed cost at 14,460. So it's changed. It's the same data, but we've added in those non-standard orders. So that's changed our fixed cost. And now we have an X variable 1, which is our number of purchase orders, cost per number of purchase orders, and an X variable 2. That's our cost per non-standard order. So we've added in a second variable. So when we do our cost formula, it's still fixed cost. So 14,460, that intercept, plus now $8.92 per purchase order, plus $20.39 per non-standard order. Okay, so it just means more math. 14,460 plus 892 POs plus $20.39 non-standard orders. We'll just put no. Go on. Okay, so that's my new cost function. So now we just plug in the givens. Well, what if they estimate that next month we have 430 purchase orders and 45 non-standard orders? Well, that would be your fixed cost plus 892 times 430 plus $20.39 times 45. Okay. So again, just adding to our function. So what would be my total purchasing cost for the month with 2 variables or 2 cost drivers? Very good, 19,213. Any questions on that? So on number 3, again, we're doing the same fun stuff, right? We're just extending it out for a year. So it's the same fun stuff. Now we have to take the fixed cost times 12. And then they told us purchasing orders are 5,340. So $8.92 times 5,340 plus 580 non-standard. So $20.39 times 580 non-standard orders.
580. Oh, yeah, this would be awesome.
Did I say it wrong and write it correctly?
30 and
I'm like, I missed. I don't even know some days, right? It's like I write it down correctly and say it wrong or vice versa. So that one's really lengthy, right? A lot of math. But what would my total cost be in that situation?
232,979.
Very good. 232,979. And then again, to get the total fixed portion, we would just take the 14,460 times 12. And how much was my fixed?
173,520.
Very good. 173,520. And I know they keep asking us the same thing over and over. Well, it's 12 months in a year, right? That's repetitive.
Just make sure it's on the test.
You'll know. Be like, we have a guaranteed one right. If someone got it wrong, I'd be like, dude, no.
That'd be funny.
You get double points off. No. Okay. Any questions? Hey, we finished early. It's like
Do you
6:38.
think there's any loopholes in the homework this time around? Because remember you were like, oh, I'm sorry, on the homework, you're gonna have to completely find your cost of goods sold.
Oh, that
so
fun
they're not
one.
gonna Give it to you. Because there's obviously more questions on the homework.
One of
itself, so
my-
I'm just trying to see if maybe you've got something.
One of my sorry, not sorries.
Yeah, basically.
Let me
Oh,
look.
See, I'm already seeing scatter plots. What the heck?
Hey, I mentioned you could graph it.
Go off, go back.
Oh. Let's see. The first one is just like one we did. Second one is 2. That one's good. That one's good. Let's
Start with
see.
number 6.
Yeah. I think that one's okay. Because you have all the stuff to do that.
I don't think there's anything.
That one looks pretty clear.
Scatter plots, you just have to know how to read it.
Yeah.
Okay. Sweet.
So yeah, we can talk about that real quickly. Basically, on a scatter graph, it's the method we didn't talk about. You know, I briefly mentioned it. But here, it's where they're taking the data, the same data we looked at, you know, and they're putting it into a graph. So you know, they're just drawing intercepts between number of tests and costs. So it's asking you based on, you know, these numbers given, which one looks right. And I know y'all all have different ones, but I can tell you, like, if it looks like this, it's not right. Most of the time when you have a scatter graph, you're looking for a line, a linear representation. So that will help you on that one once you know. I mean, I could tell you this one could be correct. This one could also be correct because sometimes you have cost outliers, you know. And then like C and D look totally bonkers to me. But the way to double check is you could actually just plot it, right? Like I could look for January, 2,800 tests, 133,500. So I would just kind of eyeball it and it looks like, okay, that's right for January. That's a point. It's one of these points. So it could be either A or B. And just kind of look and eyeball. Most of the time you can kind of eyeball and get a good idea and then just check a few points to see if they line up. What I would do is I would look at this one. I would say, well, we have one that's probably like 3,700 and like, what, 110 or something. And if I look at my costs, notice on your total cost, you don't have any total cost under 133,000.
You know what I don't see, but then they gotta go up to the chance and learn.
I think they briefly talked about it.
I think so. I need to look at it, so.
But I can tell you this one is absolutely incorrect because on my total cost, I had no cost under 100,000, and this one has points under 100,000. Yeah, I'm pretty sure mine's A. So yeah, these last two are just totally off the wall. But yeah, you can kind of eyeball it. It's just kind of showing you when we use a scatter graph, it's not really super accurate. You know, we're seeing a visual representation of the cost function, but it is less accurate than the high-low method or the regression. But yeah, they're just plotting every total cost and number of tests, every month's worth of data. So my answer is definitely A, and yours probably is too. Or the one that looks most like A. And then from there, you're just going to write a cost function too. Using high-low. So that's using high-low again. So you're using, you're just answering which scatter graph is most accurate, and then you're using high-low, which we did. So
What question is that?
that's the very last homework question.
Jeff, The first section or
It's in chapter 3 homework, and it's like the last one, number 7.
last one?
Yeah. Yeah, number 7. But yeah, it's really just looking at scatter graphs, but you're going to do high-low method on it. So yeah, it should, hopefully it'll be good. Any questions you guys have?